of you will be kind of looking at me and going, who is this person and what does she have to do with INCOSE? And hopefully that will become clear because I'm going to talk you through my journey a little bit. But part of the reason you haven't seen me for the last 15 to 20 years is I've been living in the Netherlands. So I'm more involved in these things than you might see, but that's because I'm involved in the Netherlands. So the Macpherson lecture, I had the absolute pleasure to meet Philip in 2008 in the INCOSE event in Rotterdam with Hazel and Paul, wherever Paul is. Hi. And so it's a great pleasure for me to be able to give this lecture today. And guys, the last time I was really here in the UK in INCOSE was probably 2003, 2004. And I think you need to be really proud of what you've done, really proud. But I'm going to tell you a story, so in 3 parts. The past is prologue, present is a gift, and the future is our responsibility. So the prologue. This little kid, she loved physics and science and engineering, and she wanted to be a geologist or a geographer or an explorer. But she was a teenager in the 1980s, where mostly you were encouraged to be nurses or secretaries, which are good professions, but it's not what she wanted to do. And luckily, she had a physics teacher who would quite happily say, fairly regularly, don't go looking for a knight on a big white horse to save you. Get your own damn horse. Go out and do your thing. And so I did. So against all prevailing wisdom at the time, I went off to Liverpool University and I did electrical and electronic engineering, which was a really interesting thing to do because while I loved physics, I wasn't very good at maths, in fact. Partly why I love this picture is because this is the electrical engineering building at Liverpool University, and that's where I studied. And this, at the time, was the mechanical engineering building. But this is where my grandfather studied physics and chemistry. And so this was a real moment for me, because this was where my grandfather studied, and this was where I studied. And after my studies, I actually didn't do the whole careers fair thing. I didn't get into all of that. And so I didn't quite know what I was going to do with my life. And I lived in the West Country, like quite a lot of us did. And Marconi Underwater Systems put a double-page spread in the newspaper with a list of engineers that they were looking for. And I looked at the list and I went, well, Pippi Longstocking style, I've never done any of this before, so I can probably do all of it. And basically wrote an application based on that principle. What do you want? And I had an interview with them that was 2.5 hours. And for the first 90 minutes, I didn't know what they were interviewing me for. So I just ticked the list. And they were asking me all kinds of interesting questions, like, would you have a problem talking to an admiral on an average day? And I was kind of, what kind of question is that? What's that about? Turns out they had not actually hired systems engineers for 10 or 15 years. And at that time, the prevailing wisdom was, if you wanted to be a systems engineer, you had to have 20 years of experience, you had to have seen several projects go seriously badly wrong, and have dug them out of the proverbial poop before you could even be considered a systems engineer. And they said, we've not hired for 10, 15 years, so our guys are aging out. We've got no systems engineers. So we're going to try an experiment. We're going to build you into a systems engineer. And this was roughly 1995. So from Andrew's previous slide, a little bit after the whole INCOSE guy started to get going. And for those of you who know, Bill Bardo was still on the scene. The Marconi Systems Engineering team was in full sway. And they sent me to Dunchurch Management College to do my systems engineering training. And everything they were driving was, how do we build systems engineers? How do we get systems engineers faster and faster with the right knowledge and the right depth of knowledge and understanding? So they hired me, and the rest is history. And for those of you who know, Sonar 2087, that was my project, in fact. So as part of that, we were doing the whole requirements engineering transformation and the whole defense industry transformation that was happening at that time, and really thinking about how do we do this better? How do we make sure that we're doing projects on time, within budget, and with the right capabilities? So I was extremely lucky to be part of that process and to be part of INCOSE at that time. And what I learnt, so I'm going to give you a little bit of my learnings on the road, was the V model is extraordinarily useful. Extraordinarily useful. And I still use this today all the time. And you will find this slightly strange when we get to the present and what I'm doing now. But the most important learning I got out of that was how to use the V model effectively to think about how do I tease all of this out and how do I understand the complexity that I'm dealing with. And if I'm really careful about how I do this, if I look at any particular element in the system, all I need to understand is what's going on above it and what's going on below it. And I can take that out and I can replace it with something else. And so the power of this thing has stuck with me since then. And the second little bit of learning I got is none of this technology works in isolation. You have to think about people, you have to think about process, and you have to think about the technology. If you only look at one of those pieces, it will fail. But one of the things that I found really important and started to think about is, that's great, what's the bit in the middle? Because we always talk about people and process and technology, but what's the thing in the middle? Anybody?
Systems engineering.
Close. Why are we doing it? What's the purpose? What are we actually trying to achieve? What is the point? And what are we going to take pride in once we've finished? What's the end result that we really need to drive? So then I got pulled into Telelogic. And for those of you who know, interviewed by QSS, Keith, and hired by Telelogic. And this again was an extraordinary learning experience for me and an extraordinary privilege to be working with people like Ken Jackson and Peter Brook and Stuart Arnold and then Jeremy Dick and Keith and Hazel and a whole bunch of other people. And I'm also quite curious how many people in the room I might have trained indoors at some point, but that's a lunchtime discussion. And so I had 4 years with Telelogic in the UK, where again, I was really lucky because I was able to work on everything from defense systems to automotive to, I think at one point even we were doing banking in Russia. And then to have this global experience, so at one point I was covering Russia and the Middle East. And the extraordinary breadth and depth of experience that I was able to get working here taught me 3 things. And those are, we have to keep things simple. We have to keep things as simple as we possibly can. And we have to aim for elegance. And the whole thing with elegance is about the inside of the system needs to look as good as the outside of the system. So the thing might be beautiful on the surface, but when I open this up, what's inside the box needs to look as good as look as good as the box. And why is this? Is because managing and maintaining everything is so much easier if we keep things simple, if we keep things elegant. And we have to apply intelligence. And this might seem like a strange statement, because here we are, we're a group of thinkers. If we're in this room, it's because we think about things really deeply. And we try to understand them, and we try to work them out. But sometimes we can get lost in that thinking. And we have to make sure that we are applying not just our biases and our patterns and our pre-existing thinking, but we really have to put some intelligence in how we think about what we do. And then, in 2008, which is the year that I met Philip, and also the year that I got married, strangely, I don't know how that worked out, we were acquired by IBM. Telelogic was acquired by IBM. And I expected to last about 15 minutes, in fact. I came from defense industry systems engineering. I didn't know what I was doing in an IT company. I didn't understand it at all. So I thought I'd last about 15 minutes. I lasted about 15 years. And why that happened was because once I got inside, I was able to get into, systems and software engineering, more enterprise architecture, more technology strategy, but also the whole upswell of what was happening with cloud and AI and big data and security and cyber security, and all of those different pieces and different capabilities that then I was able to pull together to solve a problem. And all of a sudden I had absolutely everything that I needed to solve any problem. And one of the things I particularly liked was the very, very simple line which IBM uses, which is think. Just think. Whatever you're doing, take time to think. And as part of that, I was lucky enough to become part of the IBM Academy of Technology and really think about things like sustainability and digitization for the digitally challenged, because we tend to design for people who are like us. We tend to think about, other people having the same level of skill and capability that we do. And I know we have all of the standards in there which are for designing for differently abled people or vision impaired people or whatever those standards are. But still, as technologists, we don't always internalize that very well, actually. And we still assume that everybody using our systems has the same level of skill and knowledge that we do. So we did a lot of work around digitizing for the digitally challenged. And as part of that, I realized I needed more capability to be able to explain ideas to other people and to be able to get them to understand why these systems approaches and these systems ways of looking at the world were so key. And what I found coming out of defense, where we were driving more and more of this systems thinking and working more and more on this whole INCOSE thing, we had a lot of like-minded people together who immediately understood. And what I realized was, once I got out into the wider world, we're quite rare, actually. And so I jumped into an MSc on systems thinking in practice to try and build the tools that would allow me to communicate this amazing way of thinking to other people. Did I lose a slide? I may have lost a slide in here somewhere. But, okay. And at some point in there, they made me the CTO for a major banking client. And what I did was, or what I saw when I got into this environment, was everybody was chasing these new technologies. Everybody was looking at AI. Everybody was looking at big data. Everybody was looking at microservices. Everybody was looking at, you name it, everybody was looking at it. And they were not achieving the results that they were being promised by the technologies. It was not working. They were all driving after these amazing new capabilities and just not achieving what they needed to achieve. And so we did a lot of deep study on this as part of the academy and part of the masters. And what we found were 5 things. A lot of companies were having a crisis of identity. And I've heard that more than once in the last 24 hours. Is organizations losing track of who they are and what they are, and driving after these technology advances and trying to position themselves with respect to the technology advances, rather than thinking about who are we, what's our identity in the world, what do we want to focus on. We also found a lot of trend seduction. So, who has an iPhone? Yeah. Who has an Android? Oh, okay. Who of you who have an iPhone would switch to an Android? Yeah. And who of you who have an Android, yeah, same, would switch to an iPhone? Yeah. Technology choices are really emotional decisions. Really emotional decisions. People buy the technology they like because they like it. And that's fine. But this was a real problem that we were seeing, particularly in technical organizations. We're going to do microservices. You're like, why? You're building an application this size. You want to carve it up to this size. And why are you doing this? This is craziness. Agile is a great example. We saw a lot of, yes, I see some laughs, a lot of, we've got to do Agile, everything has to be Agile. I had a great day one day where I walked into a client and I said, okay, I'm going to plug this in and switch it on. I said, we need user stories for that. I said, okay. I'm still going to plug it in and switch it on. And they said, but we have to have the user stories because we follow Agile and that's the process. I'm like, okay, you go write the user stories. So they spent 6 weeks with 6 of them writing the user stories. And I walked in and I plugged it in and I switched it on. I was like, hey guys, we need to think a little bit about why we're doing what we're doing. And so what I saw very clearly was Agile without discipline is anarchy. Agile without flexibility is insanity. And we have to think through with all of these trends, what are we doing and why? We also found this fool's errand. And this was all about, we want to adopt all this new technology, we want to do all this stuff, and we're racing ahead, and we've installed everything, and we're running everything, and we haven't actually taken the organization or the operations with us. And the really key one that we found was, we're running after cloud, but we haven't actually got the purchasing department to work out how they're going to buy it, because it doesn't fit with their model at all. We found fragmentation. Fragmentation was all about saying, we've carved everything up into such tiny, tiny pieces. When we try and build it up again, you guys know better than anybody, where is your weakest point in any system? It's in the integration. So the more you fragment your technology landscapes, the more you fragment whatever you're doing, the more integration you put into it, and the weaker your systems become, and the more vulnerability that you get into your systems. And then the final thing that we found was that these organizations were 100% focused on building the factory. Is it agile? Is it microservices? Is it whatever technology? They were 100% focused on building the factory. And they kept completely forgetting about what was it they were trying to deliver. What were the cakes they were actually trying to deliver? They keep building the bakery and not thinking about the cake. So what I learned in there, and this was a very long story on, a lot of the stuff that we found, but what did we learn? And what we learned was the viable system model is as good as the V model in trying to build out systems that will work. So I don't know, does anybody use the viable system model? A few hands. Thoroughly recommend, guys, go look at it. Because this is how you can start to work in your people and process and technology around your V model. This thing now, the pattern is so clear in my head, I can tell almost straight away, is this thing going to fail or not? Do I have all of the elements of the system model in there? And if I'm missing something, I know it's going to fail. No? So if you're not aware of the viable system model, I would say go and take a look at that. It will change how you see how systems operate in space. Second thing I learned, law of requisite variety. Anyone use the law of requisite variety? A couple of hands, yeah. This is another one to go and get your heads around. This is really powerful. And what this basically says is, if the thing you're using to solve the problem is equivalent in complexity to the problem, it will succeed. If it's much more complex, it's going to fail. And if it's much more simple, it's going to fail. So the equivalent complexity in the problem you're trying to solve and the solution that you're using to solve it is really important. Really important. And there's a great example of this, which I use with all my new engineers to, again, get them to think, is, anybody heard of a popo? No? So a popo is a charity that comes out of Belgium, and what they do is they train African pouch rats to detect mines. And these things are this size. They're not your average, London Underground rat. They're just under 5 kilograms. And the interesting thing with these things is your average landmine is set to detect something over 5 kilograms. And these guys are as good, or if not better, at scenting something than your spaniels or the usual dogs that you see in airports, your sniffer dogs. So they are roughly 98% accurate. And they can clear a minefield in a few hours. What they do is they set out a grid with a little lead, and the rat runs up and down the little grid, and when it finds something, it, just like a dog, it goes, found something, and somebody can come in and clear the mine. So why is this such an interesting system? Why is this such a perfect example of the complexity of the problem and the solution being equivalent? Because all I've got to do is find mines. It's not a complex problem, actually. If I go away and build a huge amount of technology to solve this, it has to be very complex. Because I need chemical analysis sniffers and electronic tongues and a whole bunch of stuff that is really technically complex. Rats are not technically complex. What's the one thing? If I've got rats, what am I going to get? More rats. So my supply chain is extremely simple. And they work for bananas. So the price of the system is extremely low. And what's beautiful is you can go to a country and you can train somebody to train a rat and handle a rat in about 2 or 3 days. And you can train a rat in about 6 weeks. So your supply chain is extremely sustainable. The solution is extremely simple. And you can train local people, and local people can solve the problem. Or I could go spend 100 million building a technical system that does the same job. I have to fly that in, I have to have maintenance and support for that thing, and I have to manage that thing over time. Well, mate, what's the smart thing to do? So I always love this example because it's an example of really think about the problem that you're trying to solve, and also look at what really is the complexity of the problem that I need to solve, and how do those equate. And then the last thing I learned, and wherever Graham is now, there, the power of rich pictures is huge, absolutely huge, as a communication tool, particularly with people who are not technical or not systems thinkers. This is a way to put your kind of systems thinking out there in a way that people can understand it and can engage with it. So that whole process of all of that experience that I was able to get, all of that cross-industry experience, but also cross-country experience, cross-border experience, and really focusing in an industry and looking at how is this industry working and where is it not working, really then brought me to, okay, if I've got the V model, I've got the viable system model and the law of requisite variety and the ability to do rich pictures, I can solve anything. It's fabulous. So then they gave me the role as CTO for Benelux and Nordics, and this was 2020, and we all kind of remember that. It was a bit hairy. We had digitization exploding at, what, 10? It depends which report you see, but it was 10 or 15 times acceleration on digitization. And this is quite scary, because this means that we built things without thinking, and we built vulnerability into our systems. And at the same time, general data protection regulation was really coming into force. People were starting to get fined. You also saw they were starting to think about building the AI Act. You had the US Cloud Act coming in, which was starting to scare a lot of European organizations, and the whole idea of digital sovereignty was taking off. And what else? There was a lot of stuff going on from 2020 through to 2023, which particularly for technology companies was, we're in a munch and we need to be in a mono. We have to find the way to calm this down. We have to find the way to get control of this and get our hands around this. And so I was very lucky at that time to be working with a lot of these clients on how do we take the tension out of all of this? How do we manage the regulation? How do we make sure that our systems are working and compliant and safe and, more importantly, secure, knowing that we've potentially built risk in because we've been moving much, much faster than we really should have been, thinking much, much faster than we really should have been. And what I realized at that point, going back to my physics teacher, Mrs. Rebenline, I wasn't looking for a knight, I was looking for a sword. And that's what I got. Double-edged sword, systems thinking, systems engineering. There's no problem I can't solve with this. No problem that I can't solve. I was about to say something and I probably shouldn't. About socks into dirty clothes baskets. That maybe I can't solve with this. But, you've got to try. So that was the past is prologue, and I'm coming to the present. And Andrew has already mentioned, I'm the CTO for Blyce. And Blyce builds tax and social security systems for governments. So we do tax, we do social security, we do data exchange, and we do permits. And we do this for small islands and developing nations. So Curacao, all over the news last week, first time qualifying for the World Cup. Whole country is 150,000 people. And these are the kinds of countries that we serve. So these small islands, developing nations, and like why? Yeah? Because I've worked in defense, I've worked in aerospace, I've worked on, I worked on Channel Tunnel Rail Link, we worked on Heathrow Terminal 5, we worked on, I don't know what. Why? Why on earth would I step away from all of that and step into a 180 people company who's doing tax and social security software for these tiny little countries. And this is why. Because when we go into these countries, this is their tax system right now. Yeah? Anyone who was doing any of this in 1991 knows exactly what this looks like. Yeah? They're in green screen. They're doing everything in paper on Post-its on the wall. And when we look at these countries, so GDPR per capita, if you look at Luxembourg, Netherlands, United Kingdom, we're up over the $60,000. The biggest country we serve is Aruba. They're just under $40,000. If you look at the actual countries we serve, I think Grenada is the next biggest. They're somewhere at about $15,000. If I pick up Papua New Guinea, we're at like 5. Yeah? And these countries, in Aruba, actually, we do the data exchange. So they use one of the big ERP providers for their tax social security. These countries can't afford that. They can't do it. But what's interesting is with our systems, and not only our systems, but really looking at that people, process, and technology. For example, one of our clients, they had a hurricane a few years ago, came through, devastated the island, absolutely devastated the island. And due to the fact that we'd worked with them to sort out how that they were bringing their tax in, and they were actually dramatically increasing the amount of tax revenue that they were able to generate, for the first time ever, they were able to rebuild out of their own coffers. Instead of having to go to one of the governments, go to the World Monetary Fund, International Monetary Fund, go to the World Bank to secure funding to rebuild. And as part of that process, they were able to rebuild their infrastructure so they could improve their airport, improve their roads, and by doing that, improve their tourism figures, which brings more money into the country and enables them to drive more initiatives and more action for their citizens. For example, I think it's nobody in the country over 65 has to pay for healthcare now. And so this is the why. Just with these systems, we're able to really change the game for these countries. And so that impact for me is key to what we're doing right now. And there are some really complex problems in here. So for example, just having guaranteed electricity is a bit of a miracle in some of these places. Having guaranteed network is not necessarily the case. You have all of the needs of a major taxation system. They have to have exactly the same needs fulfilled as the UK government, the Dutch government, the US government, but their GDP per capita is like under 5K. So how can they fund that? How can they afford that? They also have sustainability issues that they need to face. So the problems are extremely complex and also really very simple. So how do we build a system that is the right size for these countries, the right size for these organizations? Which brings me to the future. And really this journey that we're currently on, which is around right-size digitization. And this is our law of requisite variety. How do I make sure the system is right for the scale of the problem and the capability and the capacity of the country? And okay, Andrew said it, we can't solve the problem if we don't understand the problem. So we have to spend a lot of time doing the analysis to really understand what is actually needed. What are the regulations that these countries have to adhere to? What is really the necessary capability versus what is nice to have versus what is part of the zeitgeist because it's what the Dutch government do, or the UK government do, or the US government do, so everybody feels that they have to do it. What's really, truly the problem? And so this is where systems thinking comes in. So our 5 original dimensions of decision making, obviously one is technical, but we have to think about the social impact of what we're doing. We have to think really carefully about the economic impact and the environmental impact, because there are 2 sides to this. On one side, a lot of these countries are really in the middle of this global warming, climate change issue. You know, their seas are rising. They're seeing this now. So we don't want to add to that. On the other hand, there are funds that they can access when they're demonstrating that they're working more and more. You know, the UN sustainability goals will give them access to funding, and we want to make sure that we're not putting them in a position where they can't do that. This needs to feed that goal of theirs to achieve or to be able to access that funding. And of course, the political goals, because every country has its political dimensions for sure. And the advance of AI, everybody wants to be using AI, and that has to amplify the 6th dimension, which is ethics. How do we do all of this ethically? How do we make sure that we're being fair to these citizens? And how do we make sure that we're not adding technology that's actually not necessary? And this is another way of thinking about this. Ethically, I need to make sure that I'm paying my citizens in the right way and I'm receiving money from them in the right way. But I also need to think about, am I adding technology to their system that is going to make them use more energy and make it harder for them to access the bandwidth and do what they need to do? So the ethical dimension of this becomes increasingly important. And so systems thinking, thinking in context, and then systems engineering, technology in context. And so we apply our systems thinking to decide what we need to do, and we bring the dimension of sustainability and the dimension of ethics in really strongly in absolutely everything that we're doing. So there's 2 questions, and the first is how does Blyce right-size digitization? And this is really complex. So we have to provide the same level of capability as the big ERP companies without the bloat. We have to build systems that are high-performing enough, but have a low energy footprint and a low network consumption. And we have to use future technologies mindfully. I can't just throw a load of AI in this because I up my energy cycles, therefore I'm using more energy. I have to do all of this while still allowing my countries to give full compliance to the regulations. And I have to build a technology stack that's fit for the future and fit for purpose. And what you see in a lot of these countries, particularly because they have to go through government RFP cycles, they bought something 15 years ago and it's 15 years old. And we have to replace that. You know? And then we have to build our technology stack so it's appropriate to the skills and the users that we have in country. And to give you a really good comparison, if I go into Dutch government, they have 2,500 to 3,000 people in their IT department. They have 200 architects in their IT department. My countries have maybe 5 people in the whole IT department. So I have to build my systems so they can manage those systems with 5 people, and maybe one of them's actually technically educated. So for Blyce, this is the systems problem that we have to solve right now. And why am I here talking about software? It's because if we think that software is a software problem, we're already in trouble. It's not. Software is a systems engineering problem, and we have to look at it from a systems engineering perspective and how it fits into the context. And for the rest of us, so how do we all right-size digitisation? And for me, this comes down to simplicity. We have to keep things simple. We have to focus on keeping things simple. We have to keep it elegant. The outside of the box needs to look as good as the inside of the box, or vice versa. And we have to be intelligent. And with this to me is always about saying we can't be seduced by the trend or the zeitgeist or the, we can do everything with AI. Yeah, you can. Is that a smart thing to do? Maybe not a great plan. Perhaps don't do that. And so this is my call to everybody, given the acceleration of technology and the speed at which technology is going, and the increase, this constant acceleration in, now it's AI, in 18 months it's going to be quantum, guys. Everything's going to be quantum. It's getting there now already. How do we do this in a way, how do we use these technologies in a way where we keep it simple, we keep it elegant, we keep it intelligent? And why does this matter in this room? It's because this room is where you understand this. Because I've seen you do it. I've seen you do it in aerospace and defense. I've seen you do it in automotive. I've seen you do it in heavy industry, where you already think like this, and you already work to do this. It's a source of pride, I think, in this room. And for me, it's really important that we spread that out. We push that out into the software houses and into the digitization houses and the technology houses to make sure that we're not thinking software problem, they'll sort it out. It's not. It's a systems thinking problem. It's a systems engineering problem. How are we going to do this? And then finally, for all our futures, and I have to say something, you were talking about the diversity and inclusion piece earlier. When I started with INCOSE in 1996, I think there were two of us, two ladies, two women in the room, and wow, this is fabulous. I'm so glad to see that that is not the case anymore. That's fantastic. But we need more of everyone. And so I work with VHTO in the Netherlands, which is the lobbying group that lobbies government to get more women and girls into STEM. And the conversation I had with them earlier this year is those numbers are dropping again. So women and girls are not choosing for STEM careers. And then we looked at the numbers and we realized it's not just the women and the girls, it's across the board. The numbers are dropping for those people who are choosing for these careers. And that is terrifying, absolutely terrifying. We really need to make sure that we're staffing that all of the things that make our lives run, you know? I mean, can you imagine, like, how would your kids react if the Wi-Fi went down tomorrow and never came back? It's going to be a drama. It's going to be absolute drama. We have to let go of ego. And this, I was taught in Dunchurch, in the Marconi Systems Engineering training. You have to think about the system. You cannot worry about what you know, it cannot be about you. It has to be about the system and how are we going to deliver the best system. And again, in this room, I don't worry about that. I think that's the mentality. But we have to push that out. And then we have to raise our systems to be good citizens and good house guests. And again, in this room, I don't worry too much about that because again, I see that. I see what we've done in automotive. I see what we've done in defense. I see what we've done in heavy industry about making our systems more safe, more secure. But more and more, they live in our homes and they live in our hands. And they're things that our children have access to and our grandparents who That scares me more. We have to think, am I making this technology, am I making this system a good citizen? Am I making it a good house guest that I would allow into my home and into my child's hand in their phone? So that's my story and my journey and my own slight shock at ending up in a software company that does tag systems. I never ever thought that I would end up there, but I love it and I feel the impact that we're having, and I see the need for more and more of us to think about that more carefully. What is the impact we're having? How are we driving good technology? How are we driving technology for good? Thank you.
Thank you very much. We've got 5 minutes for a couple of quick questions. I want to thank you so much, Vicky. We've got one at the front here, John.
Yep.
Oh.
Hi, it's Fadil from Ryan. A question on software and software houses. We have a responsibility as systems engineers to actually carry this message to them. How do we get them to be receptive to the message? Because for a lot of software companies, systems engineers just don't belong there, it seems to me.
Yeah, this is a really, really difficult, because you see that, and this comes a little bit from, when I started out, you had an enterprise architect, and they had the whole, this was the, everything had to sit inside the enterprise architecture, and you saw the rise of the software engineer and the rise of the developer, and we got into this cult of the developer. And Agile did not help us in this, because basically it was developers driving, and Keith, stop me if I'm wrong, but I think slide number 2 of the systems engineering training said, do not let the developers dominate. Don't do that. But that's how we've grown software houses. And this whole try, fail fast, move on. We've built software houses that think that the minimum viable product is the end goal. And they don't understand always that the end goal is, I need manageable, maintainable software that will last, and particularly in your systems, most of you, for 15 to 20 years. And so this is difficult, and it does require that you spend time. And you really need to work with them to get them to understand the problem and the end goal, which is not, your MVP is not my end goal. What I need is day 4 or week 3. That's what matters. And so, and guys, this goes back to stakeholder management 101, understanding how they see the world and how they're thinking, and start to try and tune that to, I need you to understand this from our perspective. So it is work. There's no silver bullet in there, but it is work, and it is worth doing, because I see that when I've done it myself, is there is a moment where and it's, okay, now I remember I need to be delivering something that is quality and production ready and enterprise ready, and what you do is you move the pride. I don't want you to take pride in the MVP, I want you to take pride in day 4. Is it still working? How many bugs have I found? So move the pride, fundamentally. Oh, okay.
Hi, Duncan Kemp, MOD at Loughborough University. Firstly, thanks, great presentation, and I totally agree with you, systems thinking needs to be the heart of what we do. And I also agree with you that we need to kind of start pushing that into some of the wider people setting that agenda. But there's a challenge, because if we're not going to have this kind of seduction with the latest new shiny thing, how do we stop the hype cycle just driving systems thinking the way it's driven loads of other really good practices, such as Agile?
And I think there's 2 parts to this. I think one is don't stop that, yeah, because it's not bad, yeah. Like, okay, and there was a moment where I thought we kind of got there with AI, and then it went like this. But it's not bad, because it drives people to think, and it drives people to have ideas, and it drives people, I mean, some of the things that my guys are coming up with at the moment is like mind blown, yeah? Because, again, this looks like a relatively simple thing to do, but they're really coming with ideas of how can we do this better, easier, faster, and it blows my mind what they're coming up with. And they are experimenting, and I love that they're experimenting. And I think a big piece of that is building the understanding of what is experimentation versus what do we have to do to move this thing into an enterprise-ready state. And again, that's something where I think we are ahead of that, because we were thinking about this in the 90s on how do I get something from I've had an idea into my production-ready state. But I think the second part to that is putting the structure around how do we do this, and making sure that that's clear, and making sure that it's clear that we're not trying to stop you doing this, but we are going to control this part. And then I do think there's a piece of that where you are in a particularly strong position to make the change, which is to include in the curriculum why are these two things different, and why does it matter? Because that's something I see with some of my guys who are coming out, and okay, not of Loughborough, but of other universities, who are, I just want to code. I just want to code, I just want to code. And nobody's ever sat them down and gone, do you understand the impact of what you do? And there's a great guy, Phil Nash, I think, who talks about Java coding, and he's got something like 5 rules of Java coding, which helps you to write good, elegant Java code. And it's those kinds of things. It's like, what are the 5 rules for writing really good Java? What are the 5 rules for writing really good Python? I don't care what. But again, then make it a source of pride. I think what I may have learned more than anything over the last 30 years is if you poke people's pride button, there's quite a lot you can get them to change, actually. Did that answer the question?
So I'm going to have to draw it to a close here, I'm afraid. We need to move on. So please, colleagues, join me in thanking again Vicky Bunyard.